So now, so that's just some stuff about Anaconda and how that works. Yeah, and now Donna is not here, so I can show you the slides, I guess.
Can you show again how to install IRFi?
There.
Thank you.
Let's see. Jesus. My inbox gets, it's like it ends up on the second page after a day. Horrible.
What?
And there should be a space here.
Yes.
Isn't that the double equal? No.
No.
Mm-hmm.
And what's could not find version space requirement. Oh, maybe it's something up there.
Is it from here because it's the missing FP?
Yeah. Something with find. It's not. That should work. Find links. Let's see.
Find links. Is it 2 minus or 1 minus?
Find links.
Oh, it's a different.
Yeah, it's two lines. It's supposed to be dash dash.
Okay.
I wrote it wrong. Yes, okay. So it's 1 dash if you do F, and it's 2 dashes if you write the entire thing.
Okay.
Because I recognize that before find it's like, and after find
It's
the language is different.
Yeah.
Yeah.
But
So
you use a different symbol here.
yeah, it must have been done something wrong when I copy pasted the code.
Okay.
So
You are using 5th version and version you want. You should confirm.
permission denied.
But it's still working.
Successfully built. Yeah, try it.
But something didn't work.
Try to do pip freeze. And let's see if you have verify. Yeah, okay. I have it. Okay.
Freeze is. Did you
So-
have any?
Not just this.
This is put on the slides. So we just yeah. So IRFPy is a local-based Python library that you can do pip install like you just did, and then you get so IRFPy is written by RF scientists, And later you can contribute your code. So if you have some data analysis code or some useful things, we can add it onto IRFPy and everyone else in-house can install it. And then also maybe colleagues, if you're working in a project with someone from another institute or somewhere else in the world, they can also keep installed like this and get your functions. Yeah. No reinvention of wheels and lagom document and lagom tested. So I guess everyone else has a bit different idea of what lagom means, but try to keep it somewhat lagom at least. So this we already did, and then you can uninstall it, but just keep uninstall. And yeah, that's something else. Here is a good example. So there's a package that already does this with adding units. So there's a package called, what's it called? C something, whatever, it doesn't matter. It adds units to NumPy. So it takes NumPy and then it adds physical units. So when you define a NumPy array, if you use this package, you can also say that this NumPy array, all the elements are in joules or in counts or in meters or something. So when you do functions on them, it will automatically do stuff like this. So if I do here, I put R as something in the units of kilometers. And then when I do R squared, it knows that R has been squared and the units of A will be square kilometers.
What is A? Is it string?
No, it's a NumPy array.
Ah, okay. So it's two elements.
No, it's one element.
What?
So this is the idea behind classes.
Oh yeah.
So what they did is they took the class of NumPy and the array.
Mm-hmm.
So you know when we talked about inheritance of classes that you can do, you wrote your book example,
Mm-hmm.
and then we did book in library as a new class. That's what they did here. So they took the NumPy array ND class, created a new class where they just added the unit. And then they wrote all the functions that are needed to make sure that the unit is correct.
Mm-hmm.
So then you can do rescale, and you can go from kilometers to centimeters. And then you get, it actually changes the value to centimeters squared. Is that? So that's been built into the to IRFPy, but you can use it without using IRFPy too if you use this package. I will actually look up what the package name is because it's super useful. Let's see, it's here. And then it's in. There. Quantities is the name of the package. Quantities. Here. So this is the original package. So it's called quantities. So you import quantities, and then you import NumPy, and then you can multiply it by a unit. So here, if you create a NumPy array that has 1, 2, 3, enlarge this a bit, and then you multiply it by joules, it will know that it's 1 joule, 2 joules, and 3 joules.
What is J?
Joules.
U.
Joules.
Joules.
Yeah. Yeah, and you can also do it like this. Quantity. And then you get the NumPy array. and then you can, so here in meters, and then you can do dot units and change the units to feet. And then it will actually change the numbers to feet instead of meters. And it's pretty smart, so you can change it to a string, and it will automatically knows what it should change to. Yeah, and then some weird stuff. US survey acre, like acres, like the thing that they measure crop fields in. We have like corn fields. They measure them in survey acres. It's an area unit that's used in the US.
Oh, really?
Yes.
Do you know this unit?
Yeah.
Acre.
Yeah, acre.
Okay.
You've never heard it in movie?
What?
You've never heard it in movies or TV shows?
Acre?
Yeah.
No. Is it the area
Yes.
unit?
Yeah,
No.
it's
I
area.
heard first time. So it's like feet times feet or something.
Yeah.
What?
So yes.
Yeah, crazy.
So, so there's weird units, and I mean this is pretty useful for them. So if you ever want to do anything, so if you don't want to use the RFI shorthand, and this actually has a really good documentation too, so you can just use quantities instead, and then you do pip install quantities and you get.
Did they make it for US people to understand what they want to tell?
Maybe no. They probably made it because of US people.
But I don't know, in French we also have an area unit which is a totally different word from other stuff.
Really?
And it means some amount of square meters.
We have as well in Japan, but we never use it recently. Like it's very old, like old one.
What's it
I
called?
guess it's old, yeah.
Yeah.
My father uses it, but because, I mean, he's a farmer, so
Yeah.
maybe it's an old thing.
What's it called?
Well,
What's it called?
like lang, for example, language is like we have shaku, like shaku is like I don't know,
Never heard that.
shaku or tsubo. Tsubo is like for I think it's area, and we have our own unit.
Okay.
We used to have,
Yeah.
but we don't use.
Then metric system.
Okay, yeah. It's the word that we use in French. It's also used in English, and it's an SI accepted metric system unit.
What's
It's hectare in French.
hectare?
Hectare.
Oh, hey, hectare.
We use.
Yes, we have that in Swedish too. Hectare.
And it's equals to 2.4 acres.
What? 1 hectare?
10,000 square meters.
10,000 square meters. Yes.
That's
Yeah. Okay. Anyway, side tangent of physical units. Yeah. You are going. But by the way, just on you're going to encounter someone's code who uses the most fucked up units. Like I got solar system code where everything was in length was in parsecs.
Rand.
Length.
Parsec.
Yes,
Ah.
length was in parsecs. Mass was in solar masses,
Uh-huh.
and time was in some weird carbon-based atomic oscillation unit. And I was like, what the fuck was this guy smoking when he wrote his code? Like, why would you do this? So like the gravitational constant of the universe was some weird like 5. It's like G equals 5, and I was like, why?
Oh.
It's like, well, I used units so that G became 5. Like, okay, well, thanks. The Earth is like 0.000000321 parsecs away from the sun. Like, okay,
Okay.
thanks. Yeah. Anyway,
Doesn't make sense for solar system.
no,
to use this.
Yeah.
he was a cosmologist, so yeah.
Expensive.
Anyway, so IRFPI also has this data analysis packages for different missions. So, for example, if you have an instrument and you've developed a way to read the data and make it into NumPy format, you can just add it to the repository, and everyone else can just read the data and get it as a NumPy array like this.
DC is a data center.
Yes.
Therefore, the
So you need to install some additional things. So each instrument has its own project. So you need to do pip install and that project, and then you get it. And then you need to download the data too. But then you can do it with all these different instruments. Yeah, and that's and then we have more stuff on there. So Maxwell distributions, flux tools.
I don't use this.
But now you know how to do it.
Yeah.
Now you know how to do pip install.
Mm.
And on the website, there's also information what's in there. So it's just irfpi.irf.se.
But I'm afraid that to use kind of this stuff, okay, after for example, if I leave here, then my code is gonna be all depending on ERFI and
No, it will. I mean, you. So the only thing that might be a problem is updates.
yeah.
But I mean, would you update your own? Like once you've written a function that can calculate the flux, would you change it? Probably not.
Yeah.
So, and also this is open source, so you can just download all the files, and then you have it. So
Is it? So I can download up from outside.
yes,
Okay.
So you keep using it. And then if you
Okay.
Yeah.
work on it.
because this link is external.
Okay.
This IRFPI dot, you can access it from anywhere. Yeah. Yeah, and now Mats is working on this analysis of Flash. For the Flash is Mats Holmström's hybrid simulation code. So if you ever do hybrid simulations with Flash, this package will analyze the results. Yeah, and that's it. And then you can talk to Fedana if you want to add stuff on. I'm going to add my solar system simulation toolbox and stuff on there later when I'm done. I'm also putting together a conversion library for different weird things in the solar system physics field, like Kepler orbits. It's one of these things. Everyone uses them, but nobody knows how to actually convert from Kepler to Cartesian. It's like so I'm just writing functions and put them out there. I actually sat in a workshop at the ESA in Germany, and everyone has written their own function to convert from Kepler to state vectors. And 3 people got the spacecraft on different points of the Earth. And I had to walk them through the conventions. If you put an ellipse there and the orbit and you increase the eccentricity, does the apogee increase in the plus x direction? And it's no, it increases in plus y for me. And no, it's minus x for me. And yeah, that's one problem. Okay. So it's good to have a package that is tested and actually. Yeah, and that's it. We can just quickly maybe have a look. I had an idea for some homework. So now you know how to plot. And you did the FFT and the Euler integration in the first lab. So add plotting functions to that. Plot the do your own plotting functions for plotting the Euler integration, and do plot your FFT too, so you can actually see the peak spectrum, the FFT spectrum.
Is that rated with previous one?
Yes. So it's the practical task that we did. Practical task 1. You wrote some code to do an Euler integration, and wrote some.
Very good.
No, practical task 2. Yes. Yes, practical task 2. That's right.
Which one? This one?
Yeah.
That's what I haven't done. Because
so now you should add some plotting functions so that you can plot the results.
Wait, I didn't write a class.
No.
Functions.
To the. Okay, so you don't. I should have updated this text. It shouldn't say class there.
Okay.
Just ignore that.
Just add plotting in the function.
Plotting in the function, or a function that plots the output of the function. You get to choose. Because you should want to, if you want to give this function to someone else, it should have the option to plot or not to plot. So if it's inside the plot, it should have an additional input parameter that maybe has a default value.
Yeah.
So.
This one?
But yeah, that's the homework. But oh yeah, that's the old slides.
Yeah.
Yeah.
You upgraded?
Yeah, because I thought it was too much work to teach you class-oriented stuff. So we just it's updated. So you need to download the latest.
Okay.
Version. I'm going to update the slides again today, so maybe update it tonight.
Okay.
If you want to have an argument that's optional and by default something.
Yes, then you do the argument, and then you do equals to the default option.
And if it's not passed, it's fine.
Yeah, it gets that value in the rest of the program.
Yeah.
And then I wanted to do another thing, because this is fairly easy. This will take you maybe 5 minutes or 10. So this thing I wanted to do. So to prepare for the debugging lecture we have next week, I would like you to just write some text for me. So just open up this homework tree what.file, which is a file that does something. And what I want you to do is I want you to look at the file and then write down in a text document, what do you think happens in that file? What do you think the file does? And then I want you to run the code and look if it did as you expected it to do. And then if it didn't do what you expected it to do, I want to know why. So figure out why.
So if it doesn't.
Yeah.
So
Because if it doesn't, yes, okay, it doesn't. Sorry, it should be doesn't.
okay. So first I guess how it works,
Yes,
and then
you test
I
it
write paper wallet for
on a computer. Yeah,
and then how it works, and then
you run it
run it.
and test,
Mm-hmm.
and then you see how it works,
Mm-hmm.
and then you write something about how it actually worked.
Mhm.
And then if what is guessed and what it did is wrong,
Mhm.
you figure out why.
Okay. Okay.
This is a good exercise to just look at code and try to figure out what the idea is behind it. So, yeah, and that's it. Thanks for today.
Thank you.
Okay.